So here's a really quick video about perpendicular lines. Perpendicular lines are lines that are at 90 degrees to, or we might describe them as lines that meet at right angles. Obviously that's 90 degrees. If there are two gradients of perpendicular lines, they are what we call negative reciprocals of each other. And what does that mean? Well, it means if I've got one gradient and another gradient, when I multiply them together, the result is -1. Another way of writing that is that the first gradient is the negative reciprocal of the other. Let's have a look at some examples of negative reciprocals. So if this is my first gradient, my negative reciprocal of 2 minus a half, negative reciprocal of 3 minus a third, negative reciprocal of -4, positive quarter, negative reciprocal of 1/2, -2, negative reciprocal of -2/7, 7/2. Here's an example of the sort of questions you might get asked with regards to perpendicular lines. Find a line perpendicular to this particular equation here that passes through this point. So to find the equation of a line, what we need is the gradient and a point. Well, we have the point, it's 4 minus 7. M2 is what we want, and we know that that is going to be the negative reciprocal of this one that we're starting with. So the gradient here is 2/5. The negative reciprocal of that is -5/2. Once we've got those two things, we can use the point gradient formula. Y minus y1, m, x minus x1. Identify all the components that we have. Here's our m. Here's our x1, y1. Plug them in. Y minus -7, -5/2, x minus 4. Tidy it up using your algebraic skills here. We get y plus 7 minus 5/2 x plus 3. This is a line that will be perpendicular to that, and it will pass through that. So let's just have a look quickly at the CAS just to check. I'm going to do from the main screen here, type in my first equation, y equals 2/5 x minus 9. My second equation, it's hiding under my calculator, minus 5/2 x plus 3. Get my graph screen up, drag them both in. Zoom out a little bit so I can see it. Use my hand function, drag that into the right place. Analysis, G-solve. And we can see here, yep, looks like that they are 90 degrees to each other.